last time we talked about what machine learning is. Now let's talk about the problems machine learning can help us to solve. So for this short overview, for this comparison, we would like to use the same major components of each machine learning problem: experience, task to solve, and performance. Let's start with the most famous machine learning problems. So they belong to so-called supervised learning. Basically, that means only one thing, that your experience, your data have not only the features or input values, but also labels. That means you know what the model should predict for each of these set of features. Tasks we have within supervised learning are two of the most important tasks or most famous tasks. They are regression and classification. And they have quite a lot of in common, and the main component of that is, so basically you need to predict the target value. Given set of features. In our case, with chemical kinetics, it would mean that we have time as one of the features, and we have concentration. And given time, we should be able to predict the concentration. And that's exactly what our model must do. So as performance measures, we have different of them. First of all, for regression and for classification. So for regression, it would be the classical one, sum of squares error. Then we can also use mean squared error. We can use mean average error as metrics. But the most important of them that we can use as a target function is SSE. For classification tasks, depending on whether we have multiple classes or one single class we would like to predict, it might be either binary cross entropy, or it might be also categorical cross entropy. Besides that, we also have quite a lot of metrics we can build based on the true positive, true negative, false positive, false negative. So they are so-called accuracy, precision, and so on and so forth. Quite a lot of them. More of them are more complicated, more of them, some of them not that complicated, but nevertheless, as target function, in most cases, cross entropy, one of them will be used. The second types of problem is so-called unsupervised learning. What does it mean? It means that as data, as experience we collected, we have only features. So we have no labels at all. What are the tasks in this case then? Then the task is to recognize patterns we have in our features or in data. How can it work? So basically, for example, we have, let's consider two-dimensional space. We have feature 1, and we have feature 2, and we have some sort of data clause. It's a very simplified example, but nevertheless. So we basically have different fields where different kind of data are placed. In this case, so if you're talking about clustering, in this case, the task would be to recognize patterns. So the patterns, how different clusters might be placed. So in case, for example, we have additional data, we can say we can place another cluster here or another cluster here. So in such types of pattern, we would like to recognize using unsupervised learning methods. Besides clustering, we have, for example, dimensionality reduction. As I mentioned, for example, if you have quite a lot of variables that's more or less are dependent from each other, in this case, you can reduce the numbers without large information loss. Then you use less amount of features instead of large amount of features. In this case, we also have performance measures. And it might be, for example, for clustering problem, so-called within cluster distance. So basically, you measure the center of our cluster and you summarize the distance between the center of the cluster and then between every point that belongs to this cluster. Then the next type of problems we have so-called semi-supervised. Learning. So in this case, we also do have features as well as labels, but we do not have labels for all the feature sets. So we basically have some examples with labels, but most of them without labels. And in this case, we have a task to define, to get the labels for the features that originally did not have labels. And in this case, depends on the methods we can use, we have different performance measures. Then we go further, and there is another very interesting type of machine learning problems we can solve, so-called reinforcement learning, or RL. In this case, instead of features and labels, for sure we have experience, we have data, but they, in this case, called agent and environment. So basically, we have an agent that interacts with environment, and we need to optimize the behavior of the agent within this environment to make it optimal. And as a performance measure, in this case, we have so-called reward. So basically, it's reward for the agent from the environment. The better agent behaves in this environment, the higher reward is. So we considered 4 of most important machine learning problems: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We also shown some examples how the data can look like, how the problem can look like. but for sure every problem is different, and every problem might require different methods. Even within regression or classification or clustering or dimensionality reduction, there are plenty of methods or models you can use, and you can also use different performance for them, and it's up to the problem.